Hello everyone, welcome back to my channel. So in this video we'll see two problems on wave propagation. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, so in this question, the first question, we'll consider the first question. So in this question, he has given that an electric field in free space is given by this. E bar is equal to 50 cos 10 to the power of 8 t plus beta x ay cap volt per meter. And he has asked you to find the propagation, so direction of wave propagation, and calculate beta, okay, phase shift constant, and time it takes to travel a distance of lambda by 2. And also he has asked to find the wave equations at different time intervals, that is at t is equal to 0, t is equal to t by 4 and t is equal to t by 2. Okay, so E bar is equal to 50 cos 10 to the power of 8 t plus beta x ay cap volt per meter he has given. Okay, so that means we have the electric field component in the direction of y-axis only. Okay, so in the direction of y-axis only, right? So from this, what we have, omega is equal to 10 to the power of 8 radians per second, from the generalized equation which we have discussed in my previous video. So it will be 10 to the power of 8, so this will be cos of omega t plus beta x. So in the place of omega we have 10 to the power of 8, so omega is equal to 10 to the power of 8 meter per second, radians per second. Okay, so first question is find the direction of wave propagation. So as I have told you in my previous video, so how to find the direction of propagation when it is cos of omega t plus beta x. Okay, so what is the generalized form? Cos of omega t minus beta into minus x we can write. Okay, so there will be minus in the generalized form. So now it can be written, now the direction of propagation is minus x direction. So wave is traveling in negative x direction. Negative x direction. Okay, so this is how we can find the direction of propagation of wave. So based on the given data, so we can write like this: cos of omega t minus beta of minus x. So this minus x represents the direction of propagation, right? Next, second question. So he has asked you to find beta and time taken to travel a distance of lambda by 2. Okay, so in free space we know that wave travels with velocity of light. So wave travels with the speed of velocity of light. So the Vp, so phase velocity, is equal to c, that is speed of light, which is 3 into 10 to the power of 8 meter per second, right? So we know that beta is equal to omega by Vp, or Vp is equal to omega by beta, or beta is equal to omega by Vp. So omega value we know 10 to the power of 8 by Vp value is 3 into 10 to the power of 8. So beta value is 1 by 3. So beta is equal to 1 by 3. So we can write it as 0.33 radians per meter. Okay, so this is the value of beta. Next, we know that lambda is equal to 2 pi by beta. So it will be 2 pi by 1 by 3, so it will be 6 pi. Lambda is 6 pi. Okay, so also we know that suppose we want to find the time, right? So time taken to travel a distance of lambda by 2. lambda by 2 we need. Okay, so lambda dash will take, lambda dash is equal to c by, so that time I'm taking it as t1. Let t1 be the time, okay, required to travel a distance of lambda by 2. Okay, so we can write it as f1. So it implies, so what is lambda dash? So we need only for half wavelength, right? So lambda dash is equal to lambda by 2. So for half wavelength, what will be the value? So lambda by 2 is equal to c into t1. So what can we write? T1 is equal to lambda by 2c, lambda by 2c. So we have lambda value is 6 pi, so it will be 6 pi by 2 into c value is 3 into 10 to the power of 8. Okay, so this is the value of t1. So if you calculate, you will get t1 as 31.42 nanoseconds. Okay, so this is how we can calculate beta, because in free space we know that wave travels with velocity of light. Okay, so Vp is equal to c, so beta is equal to omega by Vp. So beta value will have got like this. So from beta we have to calculate lambda. Okay, so from wavelength only we can calculate time, because we need the time taken by it to travel only half wavelength. So first of all we need to calculate wavelength. So there lambda dash, so whatever we want, right? So for whatever the wavelength we want, so lambda dash we can write it as c by f1, where I have considered t1 as the time required by the wave to travel a distance of lambda by 2, right? So lambda by 2 is equal to c into t1. So t1 is equal to lambda by 2c. So you'll get t1 as this. Okay, right. Third question. So at t is equal to 0, what is the wave? So actually what is the wave equation given for you? E bar is equal to 50 cos of 10 to the power of 8 plus beta x ay cap volt per meter. So now we want at t is equal to 0. So when t is equal to, just substitute t is equal to 0. When t is equal to 0, this term becomes 0, because 10 to the power of 8 into 0 becomes 0. So this term becomes 0. So therefore in this case E bar is equal to 50 cos of beta x, 50 cos of beta x ay cap volt per meter, right? So when t is equal to t by 4, okay, right? So what is this capital T? Fundamental time period, right? So we know that t is equal to 2 pi by omega. T is equal to 2 pi by omega. So what is t here? T, capital T is equal to 4t, right? 4t is equal to 2 pi by omega. 4 into small t is equal to, because we have to find at t is equal to t by 4. So capital T now becomes, so send this 4 towards left side, so it will be 4t, right? 4t is equal to pi by omega. So what is t now? 2 pi by 4 omega, or we can write it as pi by 2 omega. So E bar is equal to 50 into cos of 10 to the power of 8 is omega, right? 10 to the power of 8 value is omega, so I'm writing it as omega. So what is small t? Small t is pi by 2 omega, pi by 2 omega plus beta x ay cap. So omega gets cancelled off. Cos of 90 plus theta, cos of 90 plus theta is minus sin theta. So E bar now becomes minus 50 into, so I'm writing directly cos of 90 plus beta x. Cos of 90 plus beta x can be written as minus sin beta x. So minus I'm writing front, so it will be sin beta x ay cap volt per meter. Okay, similarly at t is equal to t by 2, right? So when t is equal to t by 2, so what will happen? 2t is equal to, so when you substitute in this equation, so capital T now becomes 2t, right? So send this to this side, so it will be 2t is equal to 2 pi by omega. So 2 gets cancelled, t is equal to pi by omega. Okay, so what will be E bar? E bar is equal to 50 cos of omega into pi by omega plus beta x, ay cap, ay cap. So omega and omega gets cancelled off, right? So omega and omega gets cancelled off, so you'll get cos of 180 plus theta. So cos of 180 plus theta is minus cos theta, so E bar will be minus 50 cos of beta x. So cos of 180 plus theta, so cos of 180 plus theta is minus cos theta into ay cap volt per meter. Okay, so this is how we can find the wave equation at different time intervals given. Okay, so use this formula of time period, fundamental time period. Okay, so and we should have some knowledge on trigonometric functions, so thereby you can easily find the propagation of wave, right? So propagation of wave direction, beta, if you want to find, you can find beta, so you can find Vp, but this is a free space, so Vp is equal to c, right? So then lambda, so different parameters of the wave and the wave equation at different time intervals can be found like this. Okay, so next we'll see one more problem on this, right? Wave equations. So he has given h bar is equal to 0.1 cos of 2 into 10 to the power of 8 t minus kx ay cap, right? So and asked you to find k, lambda and t. And second question, so he has asked to find the time taken by the wave to travel a distance of lambda by 8. Okay, so same procedure as the previous problem. So here we have omega is equal to 2 into 10 to the power of 8, right? So Vp is equal to c, which is equal to 3 into 10 to the power of 8 meter per second. So this will be radians per second. Okay, so first of all we'll calculate lambda. So lambda is equal to c by f. So what is f? So f is 2 pi f, so omega is 2 pi f, so 2 pi f is equal to 2 into 10 to the power of 8. So 2 and 2 gets cancelled, so f is equal to 10 to the power of 8 by pi hertz. Okay, so once you have f, we can find lambda. So lambda is equal to 3 into 10 to the power of 8 divided by 10 to the power of 8 divided by pi. So 10 to the power of 8, 10 to the power of 8 cancel, so it will be 3 pi. So lambda is equal to 3 pi. So if you calculate it as 22 by 7, so you'll get around 9.425 meters. Okay, so this is the value of lambda. So from the equation, so if you compare, so cos of omega t minus beta x, so in the place of beta now you have k here, so k is equal to beta. So in the first question lambda we have already found, so next we are solving for k, so k is equal to beta. So what is beta formula? Beta formula is, so if you found beta, then it will be equal to k, right? So beta is equal to 2 pi by lambda, right? So we have 2 pi by lambda is 3 pi, so 2 pi by 3 pi, so pi gets cancelled, it will be 2 by 3, so beta, and also this is the value of k, so is equal to 0.667 radians per meter. Okay, so this is how we can find the value of k. So k is equal to beta from the generalized expression. So if you compare these two equations, so k is equal to beta, so you have got the beta like this. Next, fundamental frequency. T is fundamental frequency. Fundamental frequency is 2 pi by omega. 2 pi by omega. So 2 pi by, what is omega value? Omega value is 2 into 10 to the power of 8. so 2 into 10 to the power of 8, so 2 gets cancelled. If you solve for this, so it will be 31.42 nanoseconds. Okay, so thus first question is completed. Next, the time required for T1. So same procedure, so lambda dash is equal to C by F1. So if the time given is T1, so consider the frequency as F1. So lambda dash is equal to C into T1. Lambda dash is equal to C into T1. So he has asked you to find at the distance of lambda by 8. So lambda dash is now lambda by 8. So lambda by 8 is equal to C into T1. So what will be T1? T1 formula will be lambda by 8C. So what is lambda value? Lambda value is 3 pi, right? Lambda value is 3 pi. So 3 pi by 8 into 3 into 10 to the power of 8. Okay, so 3 gets cancelled. So if you solve for this, pi by 8 into 10 to the power of 8 in nanoseconds, if you solve for nanoseconds, so it will be pi by 8, okay, into 10 nanoseconds. Pi by 8 into 10 nanoseconds. So if you find this value, so you'll get it as 3.927 nanoseconds. Okay, so this is how we can solve the problem. Second question is also completed. Okay, similar kind of problems I have taken, but it is required. Okay, so all these concepts are very important. Okay, so let us take one more last problem in this video. Okay, so in this problem he has given that E bar travels in free space, right, with a wave equation like this. So and has asked you which of the following is correct. By giving 4 statements, he is asking you so which of the following is correct. Okay, so from the given data, so E bar is equal to 50 sine 10 to the power of 7t plus kz ay. So sine or cos, okay, no problem. So it will be only phase shifted version, right? Cos of omega t plus beta z form. Okay, so cos of omega t plus beta z form. So right, if you are confused with this, you can write sine also. Okay, so sine of omega t plus beta z also you can write. Okay, so no problem, because only a phase shift of 90 degrees, right? So but the direction of propagation does not change, only phase changes. Okay, so sine of omega t minus beta of minus z. So now what can we say? So wave is traveling in negative z direction. Okay, so minus z direction. So he has given that wave is propagating along y-axis, so option A is wrong, right? So second option he has given wave attenuates as it travels. So there is no attenuation factor here, right? So 50 into actually the attenuation factor if he has given, so it will be around 50 into e power minus 2 or e power minus 10, anything. Okay, so e power minus is there, so then we can say that wave is going to be attenuated. Okay, so that is amplitude decreases, but he has given only 50, so everywhere the amplitude is constant. There is no attenuation factor involved in this wave equation, in the given wave equation, so wave does not attenuate. So this option is also wrong, right? So we have to find the values of lambda and k. So what is k value? So k is equal to beta, right? So k is equal to beta. So as wave is traveling in free space, so Vp is equal to 3 into 10 to the power of 8 meter per second. So omega is 10 to the power of 7 radians per second, right, from the given data. So this is omega t, so omega is 10 to the power of 7. Okay, so what is the value of beta? Beta is equal to omega by Vp. Omega by Vp. Vp is equal to omega by beta, or beta is equal to omega by Vp. So 10 to the power of 7 by 3 into 10 to the power of 8, so it will be 1 by 30. So 1 by 30 is 0.033 radians per meter. But he has given K, so this is also equal to K, right? So K is equal to beta, so K is equal to beta, so this value is also K. So he has given, but K is given as 0.33 in the option, right? It is not 0.033, so this option is also wrong. Okay, so let us find the value of lambda. Lambda is 2 pi by beta. Lambda is 2 pi by beta, so 2 pi by 1 by 30, so it will be 60 pi. 60 pi, so if you calculate this, it will be around 188.5 meters only. Okay, so this is the correct option. Okay, so based on the given options, we can find the correct option like this. Okay.